Thank you for joining the Fire Suppression Systems Association's webinar on Detection and Control for Special Hazard Applications. Your phone lines have been muted. If you have any questions during the presentation, please type them in the question box on the bottom right-hand side of your webinar controls, and we will take them at the end of the presentation. This webinar is being recorded and will be available to download alongside with the slides after the presentation is over. With us today, we have our webinar chair, Todd Stevens with Canistraro, and our two presenters, Jeff Kidd with the Hiller Companies and Dan Corbett with Honeywell. I'll now turn the mic over to Todd to introduce our presenters.
Thank you, Becca. Good afternoon and welcome to another installment of the FSSA webinar series. My name is Todd and I am the chairperson for the webinar committee, and I am pleased to introduce to you today's presenters. The topic, as Becca had mentioned, is detection and controls of special hazard applications. We have two great presenters today, starting with Dan Corbett. Dan is a senior sales application specialist at Notifier by Honeywell. He has been involved in the life safety business and been with Notifier for over 27 years. He's held a number of positions with the organization, including test and repair technician, technical support service supervisor, associate product manager, manager, and sales application.
One thing to note as we're talking about ionization detectors, that due to concerns over the small amount of americium or the small amount of radioactive material contained in ionization detectors, as well as advancements in other detection technologies, ionization detectors have been discontinued as far as being a system-connected devices. You still might be able to go into your local Home Depot or other type of hardware store and see a detector that might have ionization technology, but from all the major manufacturers
Yeah, that's correct, Dan. We've seen a decline in the availability of ionization smoke detection over the past few years. Typically, they were more responsive to a flaming fire, to a fast flaming fire, and Photoelectric was much more susceptible to picking up smoldering fires. But the issues were always there. They were much less effective in high airflow environments such as subfloors or above acoustical ceilings, and would actually cause trouble conditions with excess exhaust or airflow going by them. So, it's been encouraging to see the advances in the photoelectric technologies, and having one particular flavor of detector out there is a lot more advantageous for the designer.
Is going to come at a certain levels because particularly with intelligent addressable photoelectric smoke detectors, they can typically be programmed for different sensitivity levels, which means how much obstruction or how much smoke is going to need to enter the chamber before that detector is going to enter into an alarm condition. Here's just a picture of internal workings of how the photoelectric works. As smoke starts entering into the chamber, the light beam gets reflected, and that's going to cause the detector to enter into an alarm condition.
Yeah, this has been the most widely used smoke detector in special hazard smoke detection, if you will, for many years now. It performs better in high airflow environments than the traditional ionization, and its early warning capabilities makes it much more responsive to a smoldering or fire or products of decomposition coming off of failure of parts, if you will. It can be susceptible to contaminants such as refrigerants causing false alarms, debris, but the industry's done a very fine job on utilizing chemically etched screens that won't let any large particulates obstruct the photoelectric sensing chamber. So they've been really, really stable.
Thanks, Jeff. Also take a look at some multi-criteria detectors. And with the multi-criteria detector, these are going to be detectors that incorporate multiple detection elements or technology, enabling one device to send multiple signatures to fire. So it's going to allow them to more quickly identify true fire events while still maintaining immunity to nuisance alarm conditions. Okay? And there's a number of different multi-criteria detectors available with various numbers of elements and technologies, as well as features and capabilities associated with those multi-criteria detectors, and also which is the front-end control panel of which those devices are connected to.
Yeah,
Dan, an example of one where it might, sorry about that. This is one where it might incorporate something like a CO cell. It might have a ability to look at photoelectric and thermal, and then it also might incorporate some type of infrared light, and then it could be just a combination of 2 or 3 of these technologies. Take it away, Jeff.
Yeah, this has been an ideal detector for very dirty conditions where nuisance alarms due to maybe some residual smoke or heat within the hazards, if you will, in mines or in very, very dirty industrial conditions, where the groups of the detection methods are now required to act before activation of the detection unit, you actually would get some early indication of the other sensing elements as well, detecting those particular disciplines, whether it's thermal or photoelectric through the smoke or excessive CO or even some IR. So it's a wonderful detector for special hazards. It does come at a cost, which is typically around 2.5 times your typical standard photoelectric spot detector, but it certainly has its place.
Another type of detection widely used in various aspects of fire suppression and fire safety in general is air sampling detection. So this is going to consist of piping or tubing distribution network that runs from the detector to the area or areas to be protected, and then an aspirating fan within the detector housing draws air from the protected area back to the detector through those sampling ports or piping or the tubing. At the local detector, the air is then analyzed for particulates associated with fire. And there's a lot of technology that's been built in to air sampling detectors. Air sampling, and they think mission critical automatically, and that's absolutely an area where aspiration can be applied. But there are many, many other areas where aspiration can be applied. Sometimes people think about the early warning mission critical and think, oh, if I go with some type of aspiration product, that's going to lead me in this type of environment where I'm into, that's going to lead me to get either nuisance alarms or false alarms, and that's really not the case these days anymore with the technology that's built in to a number of these detections, a number of these air sampling detection devices, from being able to sample out large particulates so it doesn't even come in the chamber, the ability to properly analyze that based upon all the expertise that has been associated with air sampling for a number of years, that it can really be used for very early warning and where I need to have a really low sensitivity. They can also be used in other areas where I need to have just a standard sensitivity level, but I want to have more variant. It can also afford some instances where it can reduce testing time too, because now we can put in some type of test port and test that locally, as opposed to getting up, if I had regular spot detectors there, and going up and testing those individual spot detectors individually.
I'd agree, Dan. And air sampling is the oldest smoke detection method we know of. It started back in the 30s and 40s. Marine, we had air sampling on ships where we would sample from the same piping we would discharge CO2 from. And it's come a long way from the cloud chamber to xenon, now where we're at now. It's widely used in communications, electronic, and mission critical facilities, and really applied this product to high airflow environments, to areas that have massive change in temperature. Being 1,000 times more sensitive, or capable of being more sensitive than your typical spot smoke detector, it really allows us to pull a sample back from that hazard and analyze it and pick up a fire or a possible fire condition in its incipient stage, when we have component failure within a server that starts to heat off and give off those byproducts of decomposition. The air sampling has been absolutely phenomenal with giving us an earlier indication prior to your typical spot smoke detection activation of 2 to 3% obscuration, giving us an early indication locally so personnel can address it, whether it's shutting the server off or removing it from the hazard, and really ensuring business continuity, not discharging the suppression system, not deploying the red trucks. It's come a long way, and it's a very, very important detection tool in the special hazard fire protection toolbox.
So we talked a little bit about the technology. Jeff did a great job of elaborating on other areas where it's going to be applied. And I'm going to assume most of us are probably fairly familiar with air sampling. For maybe those of you that might be not quite that familiar, once you run the pipe network around, it's going to come down to drilling the appropriate size hole, in the right area on the pipe, facing the right manner, and depending upon what it is that we're trying to protect. And basically, each one of those holes becomes equivalent to a spot detector. So this is also where, if I think about a large area where, when maybe upon initial installation, it was fairly easy to get to those spot detectors, but now as the process has been built out, just when I have to go in there and do that testing, if I had to get in there with scissor lifts or whatever I need to do to get into vision of those spot detectors, this is where, an aspiration type system, to expand upon what Jeff talked about a little while ago about, yes, it's going to provide that early warning, can also provide me the ability to do early warning, sensitive to very sensitive, as well as can maybe help reduce some of the testing time associated with the typical spot detection system.
Absolutely, Dan. And one of the things we should touch on is sometimes air sampling does get a bad rap, and that's usually due to the stability or the original setup or servicing of the unit. You'll have a computer manager say that box has always been in trouble. It's had the yellow light on since the day you installed it. It really goes back to the way that we supervise the placement and the sample holes of the piping. We set low and high airflow values on the piping, on the commissioning of the system, so that in the event that holes are blocked up, we will get a low airflow fault, and in the event that the piping's compromised, broken, or separated, we get a high airflow. And that's as per NFPA 72. We have to follow these practices. And it's crucial that when these particular devices, any air sampling system is commissioned, designed, installed, programmed, what have you, it's done by competent personnel and serviced on a regular basis by competent personnel. If properly set up and programmed, there should be absolutely no issues with air sampling detection. It should sit back dumb and happy on your wall, do exactly what you intended to do. But it is sometimes the black eye is the air supervision, if you will. But it's something that can be taken care of on the initial installation, and as long as it's serviced regularly, should not be a problem.
Yeah, thank you. Another type of detection that's going to come into play is also going to be heat detection. So here there's a number of types. There's fixed temperature heat detectors, there's rate of rise heat detectors, combination heat detectors that incorporate a combination of those. There's also linear heat detection that we'll talk about. So heat detectors are definitely one of the oldest type of automatic fire detection devices, not considered a direct life safety device, but these detectors do contribute to the detection of a fire, and there's some applications where it might be the only thing you can use just based upon the environment and the process or the area of which you're trying to apply that protection.
Correct. Yeah, and with fixed temperature detection, again, one of the oldest means, whether it's a mechanical fusible link or an electrical heat detector, it's a very stable detection of a set temperature. The disadvantage is it's not really capable of detecting a fast-growing fire due to a rapid temperature change. It's going to really want to only activate when it sees those temperatures. Rate of rise, again, it quickly detects a rapidly growing fire or heat source. Again, it can be subject to false alarms in rapid heat fluctuation environments, such as heat quench processes. Recently, we had an installation of a heat quench process, had 450-degree heat detectors, rate of rise in the exhaust duct, and the system discharged prematurely. Upon investigation, the thermocouples in the duct were reading 310 degrees. Well, why is it going off? Well, what we didn't know is at the beginning of the process, a large flame would be introduced as soon as the door was open for the new basket. And that would cause a rapid temperature fluctuation in the duct, going past its rate of rise, set points, and discharging the system. So for that application, we had to go back to fixed temp. Combination, rate anticipated and fixed temp. There's a wide range, variety of those on the market today, anywhere from 140 degrees F to 725. But again, it is susceptible where rapid heat fluctuation within the hazard might be an issue.
Here's just an example of maybe the internal workings of a heat detector, where you have your fixed actuator that might activate, and depending upon what type of heat detector it was, if the fixed actuator were to activate, it might need to be replaced. If it was more of an addressable type system, then it would just activate and then it would self-restore. So it's just a little bit of the way we might look at the internal workings of how we get that alarm contact to activate associated with the detector to sensing heat. There's also linear heat detection. So all the other heat detectors that we talked about, and Jeff did a great job elaborating on, was those were spot type heat detectors, where they're gonna cover a specific, different size buildings or larger ceiling heights that spacing might get reduced. With linear type heat detection, now linear type heat detector basically has a device whose sensing element comprised in one type, two current carrying wires that are separated by heat sensitive insulation, and as it's exposed to heat, the insulation softens at that rated temperature which it's been designed for, and that would allow those two wires to make electrical contact, and that's how we would get the signal. So, and nowadays there's various options that now exist for linear heat detection. There's some that work off of fiber. There are some that can be installed that actually pinpoint the specific location. There are some thermal cable that you would just know somewhere where this thermal cable runs, I'm sensing heat. There are others that can be designed in such a way where it can kind of pinpoint almost a specific location of where along that linear cable has the event recurred from.
Absolutely, Dan. It's ideal for outdoor applications. We use it regularly. Other hazards that may be outside of the temperature range or listed temperature range of typical spot type heat detection, such as freezers, or up here in the Northeast, outdoor tank farms, if you will. They also come with various shielding or coverings on the linear heat detection cable, some of which are less susceptible to caustic and acidic environments. We use those type of products in semiconductor manufacturing facility. Wet benches works absolutely wonderfully. As far as testing, you can run the cable inside the hazard, bring it back outside, and have a testing point. It's a very cost-effective product and installation for the coverage it provides. We use it in hangars where spacing and height concerns, as you mentioned, are a problem. Some of the disadvantages, it is easily susceptible to damage. That's been the problem. That has caused false alarms with kinking or shorting the cables together. But is properly installed, it does do very, very well.
Another detection that could come into play is going to be flame detectors. And flame detectors respond to a presence of flame or fire. There's a number of different technologies that are available out there. They're used in applications. Again, this is another thing where we're going to cover just some of the applications where flame detectors come into play, but it would be either chemical or petrochemical, aviation, oil and gas, a number of manufacturing, such as if you're doing any type of process where you have paint booths or anything like that. That's where you're going to see some flame detection, and I know that I'm sure that Jeff can elaborate a little bit more on some of the technologies and where we're seeing them being applied.
No, you're absolutely right, Dan. There's such a wide range of applications for optical flame detection. Flammable liquid storage, flammable liquid load unload stations. Again, semiconductor manufacturing tool and process protection, whether it's on the bench or within chemical cabinets. Ideal for detecting a very fast flammable liquid fire. Pharmaceutical is the development and manufacturing of pharmaceuticals. Flame detection is widely used. Healy could probably tune into this. Automotive manufacturing applications, paint booths, processes that require fast-acting, wide area of view protection. Very, very effective. I know American Fire does some work with mining vehicles and tools, large mining tools, and optical flame detection is used to protect these very, very expensive assets used in the mining industry.
Thanks, Jeff. So we looked at an overview of what a special hazard fire suppression system is. We talked a fair amount about some of the detection and the different technologies, different capabilities. And Jeff did a really nice job explaining where they applied, some of the benefits, and as well as some of the things to watch out for with some of those different technologies. Now, but all of those input devices of what we've talked about thus far, well, they need to connect into something. They need to connect into a control system that can be used for special hazard fire suppression. So let's take a look at some of the types of different systems or some of the requirements associated with that. One is it should be listed for the application. So what standard or standards does it need to comply with? Jeff alluded to this earlier. Definitely should be designed and installed by a trained and certified personnel, so that we're making sure that we're using the right technology to protect that hazard. Also, for a number of things, it's got to be used with listed compatible equipment, such as the solenoids and or actuators that are going to be connected to the system. That's going to, based upon the requirements of that system, when either someone activates that manual release pull station, or is it going to be a single zone type of hazard or a cross zone type of hazard? Do I need to have some type of delay equations in there? That's all going to be handled by that front end in order to properly activate the listed solenoid. Any type of loop or zone powered smoke detector, so it's a conventional type system, 2-wire smoke detectors, or addressable systems that need to make sure that the detectors are using are listed with the equipment, and for doing any type of synchronization for the strobes, and typically there's going to be a requirement for any strobes that are being synchronized to also be listed as compatible equipment.
I'd agree. Everything should be third-party tested and listed and approved. Should be designed to fulfill all UL and NFPA requirements. That's a standard that's throughout the industry. Unless you receive equipment from overseas or out of the country, it's typically not an issue here in the U.S.
A couple different types of control systems. We're going to talk about a conventional. So we talked earlier about some conventional devices. So those conventional devices, would connect into a zone of a conventional panel. So a conventional panel is a hardwire zone panel where the devices do not report their specific location. It's typically the simplest type of control unit. Generally, not always, generally a single circuit board would be like the whole system that would contain the power supply, the control unit, the input circuitry, the output circuitry as well. Input and output devices typically connected to dedicated circuits. Designated outputs occur when the initiating signals are received. Typically limited special functions and capabilities. When we get into larger type addressable releasing panels, are typically a little more sophisticated as far as the programming goes. And just to note that the number of releasing outputs or the capabilities for any conventional and or addressable system, that's going to vary by manufacturer. Just please reach out to the manufacturer or their authorized representative for more details.
Yeah, absolutely, Dan. And these are really the heart of our smaller systems in special hazards. They're a typical conventional fire alarm panel that's been modified, tested and approved for releasing. And they're fixed power limited circuitry typically on one board, including the initiation, NAC, releasing, supervisory circuits, and Form C relays, all on one board. They also have constant and typically resettable 24 aux power for either optical flame detection, resetting, or duct detectors. They do have limited programming capabilities. You typically will have detection configurations consisting of either, counting or cross zone or even a single zone release. You'll have 3 or 4 board functions to be programmed, pre-discharge delays, manual release delays. Typically, these systems are single releasing zone. Some manufacturers make conventional systems that can do 2, but no more than 2. A very cost-effective, a very easy way to put everything in one package, in one panel for one system, whether it be clean agent or carbon dioxide or dry chemical or the whole range of the special hazard extinguishing agents we have available to us.
Great. Here's just an example, maybe not to be the best example, of a conventional type system where we could see now for every zone of smoke detectors or pull stations I'm going to have, I got to have a dedicated pair of wire that's going to go to that device, and if someone were to activate the last smoke detector on any of those zones were to activate, we would know locally at the panel that zone activated. We would not know locally at the panel specifically which device activated.
Yeah,
now we move on. Oh, go ahead, Jeff. Sorry.
It's just a typical riser diagram of the conventional detection. And the initiating accepts a limited number of listed spot smoke detectors per detection circuit. We need to be cognizant of that. Total limited circuit resistance needs to be observed, whether it's inputs or outputs. You have limited NAC currents out of these conventional systems, so you really have to do your calcs on your audible circuits. Typically, the initiating is a Style B or Class B initiating device circuit to a Style D or a Class A, whether it's built on the boards or accessory boards can be added to these conventional systems to make it Class A. NACs are typically Style Y or Class B, or they can be Class Z or Class A for outputs if with onboard terminals or additional Class A boards that can be added after.
We'll take a look at an addressable or intelligent system. Now, this is a smart system, where each device is going to report a unique address to the panel. Since that unique address is coming back to the panel, now we can, identify the specific location of the alarm and/or trouble. These are generally an engineered type system that's going to be, configured by either the manufacturer or the manufacturer's representative. That's going to be configured with the, the appropriate CPU, the appropriate number of power supplies, or the right size power supply. What other auxiliary equipment do I need to add into the local control panel, or potentially into some, distributed control panel to meet the requirements. Easy distribution of detection and control modules by the SLC loop. So now, if we think back to conventional, I don't have to have a dedicated, set of wire running from this as far as the operation of the panel goes. I could have one SLC loop run about through that entire facility. I can install my devices on the SLC loop. Everything's, as far as input and output function, is really going to be coming back to the programming of the system. So it's a much more sophisticated system and much more flexible for programming compared to a conventional system. Typically has much more advanced functions and capabilities where you have the ability to write in, some type of logic zone where I'm doing cross zoning, or maybe if it's incorporating some type of heat detection or flame detection, that the heat or the flame still needs to be active for this to happen. So it can be much more sophisticated. And again, the exact capabilities of any specific panel, that would be, please contact the manufacturer or one of their authorized representatives for that.
Absolutely, Dan. We've come a long way in addressable release and control systems over the past 20 years. They're all equipped with multiple software releasing zones nowadays, where you could do multiple hazards per one system, with, like you said, mappable capabilities of overlapping hazards and releases. They're capable of time in and time out for special applications such as low pressure CO2 or water mist or even high expansion foam control. It just really gives us a lot more flexibility and breadth over the conventional systems, and it comes up. Where is our price point? Where's our break point? When do we go with individual conventional detection and control panels to one large addressable? How many zones? How many releasing zones? Cost-wise, we start thinking about it around three hazards, and you're really going to start to be more cost-effective with an intelligent addressable system, and offering a lot more information locally to the front of the panel, being able to enunciate that remotely really is an advantage.
Here's just a kind of another simple example of a addressable system with an SLC loop. This case, it happens to be a style 6 loop or class A loop, or it's returning back. This particular example, right, one of those smoke detector activates or one of those pull station would activate. We are going to know specifically, and the operator is going to know specifically now back at the main control unit exactly what device activated, what type of device is it, and where is it located. So we did we had an overview of special hazard systems. We talked a fair amount about the type of different technologies and detection principles, and Jeff did a really good job of explaining, where we might apply them, where not to apply them. Now to kind of wrap up this part of the webinar today, Jeff's going to talk a little bit about some of the agents used for extinguishing for special hazard fire suppression.
Well, thanks, Dan. And again, this is a subject that Todd did an entire webinar on. Was basically clean agents, but these are just a few of the extinguishing agents we have in our toolbox that we connect and control with special hazard fire protection panels and detection processes. Obviously, clean agents, we use electronic data processing, control rooms, high hazard, high value facilities, and we've used, again, both conventional and addressable with listed releasing devices for those control systems. The next we have is, we had noted carbon dioxide, clean, colorless, gaseous extinguishing agent. We use it in either total flooding or local application, high pressure or low pressure, very effective on Class C electrical hazards, Class B flammable liquid hazards. We would typically use either spot heat detection for detection of a fire, or if we need to detect it real fast, we'd use optical flame detection. Typically, a Multicriteria or a UV-IR or a triple IR. The last, and we were running a little bit out of time here. Dry chemical, again, another engineered solution we have, and pre-engineered, that we commonly would connect to a listed control system for flammable liquids, paint spray booths, if you will, very effective on Class A and C fires as well. Last, we have wet chemical, which is a pre-engineered. Oftentimes, this does not have an electronic control system. It would be mechanical means only, but in some situations they do. Wet chemical we use for grease fires in hoods and in cooking processes. Foam, we use detection and controls in foam in hangars and flammable liquid storage rooms. In tank farms, we typically would use fast-acting flame detection to cover wide open spaces and rapidly detect a flame fire over 1 square foot and deploy the extinguishing agent, whether it's AFFF expansion foam to us now, which are engineered systems that combine multiple extinguishing agents such as nitrogen and water. Again, they incorporate the same listed detection and control means as we would with any other hazard. And that brings us very rapidly to the end with questions.
Awesome. Thank you, Jeff and Dan. We do have a couple of questions that came through. If anyone else has any additional questions, please type them into the question box now. So our first question that we have, are there standards requiring any specific type of detection related to special hazard fire suppression?
I'm not aware of any. I know there's some things about like NFPA 75 and NFPA 76, Jeff, that cover certain.
Right. There's best fire protection practice in selecting detection methods when dealing with NFPA. And some other authorities having jurisdiction like FM Global will depict what type of detection method they would prefer, let's say in a high airflow environment in a data center, air aspiration. It's to really do a thorough hazard analysis to determine what the hazard is, what the fuel is, what the potential for a flaming fire or a growth is, and select the detection method based on it. How fast do they wish to pick it up? And it's also it's also, you can go back to the manufacturers of that particular suppression system and get their recommendations as well.
Cool. So the next question is, required to be listed for use with the system?
Absolute. Control systems will have a list of the releasing devices that they went to UL, and that means that device is approved for the releasing from that control panel, whether it's a hard or it's a releasing module off of an addressable panel. Those devices. This is really pertinent in upgrades and swap outs of older systems. It's imperative to make sure that these devices are listed with what you're installing.
That's a great point, Jeff, especially when you talked about like in a retrofit. Just in case anyone's not aware, prior to, if anyone else remembers, when UL 864 roll around, that was a big. That was 9 fixtures were now required to get the solenoids listed, just very similar as we do a 2-wire smoke detector. So to Jeff's point, if you're doing a retrofit where someone like, well, when we put it in, we didn't need to be concerned about that. Well, now there's a new standard that now you do need to be concerned with. To Jeff's point, definitely needs to be listed, and all the manufacturers would call out those compatible devices within their documentation.
Very good, Dan.
All right, so the next question is mercantile occupancy, which was an unexpected finding. Are there any specific types of mercantile occupancies where aspirating detection might be appropriate?
I would absolutely say yes. I believe that we are really on the verge of seeing an increase in air aspiration detection because of its ease of installation, and some manufacturers have gone from pipe to tube. The testing of these systems, the single point, the communication capabilities, we are starting to see more in commercial applications than we had in the past, where it was primarily industrial. But no, I believe we're going to see a lot of growth in that area in the years to come.
I would agree, Jeff. We're seeing it pretty much applied in all areas of detection.
Yeah.
All right, the next question. When using multi-criteria detectors in special hazards, does the sequence of operation change?
I'll answer that by no. It is still.
I would agree.
Where it's just if you will, it has more confirmation features to confirm a fire condition, or at least particulates of decomposition and optical and CO, if you will. It would still act as just one detector in the sequence, whether it's whether you're in a counting or a cross-zone scenario for the releasing of your extinguishing agent system. It would just play one role. Again, you would be able to also receive early indications of those excesses, from the control system in the event that it saw some CO or smoke or even some IR before all of those were satisfied to put into alarm.
Yeah, I would agree, Jeff. And to my knowledge, I think everyone's that has a multi-criteria, it's still kind of one point on the system. But
Yep.
Some of them have the ability to say, oh, the heat detector activated. I can create some type of different function. That's going to be kind of the detector and which manufacturer control panel it's connected to.
Great.
Okay, next they're asking, what are the...
Well, we'd follow NFPA 72, but as an industry standard, we typically use 250 square foot unless otherwise specified in releasing system scenario. 250 square foot ceiling subfloor above unless, again, you have an HJ like FM Global, that would require you to go down to 125 foot spacing per detector. There's no actual required.
All right, well, this is the last call for questions, so we'll wait another 30 seconds in case any more questions come through, and then we'll wrap up the webinar. All right, so no other questions came through. We will thank you once again for joining us this afternoon for FSSA's webinar on detection and control for special hazard applications. As a reminder, the presentation and slides will be available on the FSSA website by the end of this week. We look forward to having you with us on the next FSSA webinar. Thank you.